In this video, we're going to take up the homework for a function or relation. So for every relation we have here, we're going to see if you have a function. Okay, so y equals 5x. Hopefully you can say that's a function because, well, there's a few ways you can do this. You can graph this out and see that it passes the vertical line test, or you can just study the equation. You sub in a value of x and multiply by 5, and you're only going to get one value for y. You're not going to get two different values for y when you take a number and multiply by 5. Y equals 8, once again, you can graph this, it's a horizontal line, or you can just study the equation. In fact, this is a constant function. It's a constant function, which means, yeah, it's a function. Okay, it doesn't even matter what x is equal to. Okay, now here, plus or minus root x, that is a relation. That is a relation because you can obviously tell from the equation, when you sub in a value of x, you can potentially get two different values for y. All right, now for the next two examples, you're given graphs, so all you have to do is ask yourself, does it pass the vertical line test? Yes, so it's a function. No, so it's a relation. X squared plus 2x plus 1, wait a minute. That's very special actually, the quick square trinomial on the right side, but you know what? More generally speaking, it's a parabola. And if you have a parabola from grade 10, then you definitely have a function because it passes the vertical line test. Okay, and if you forgot about that, what you can do is just study the equation. You have x squared plus 2x plus 1. So no matter what you do, no matter what value of x you sub in for this equation, it's only going to spit out one value of y. If that's the case, it's a function. Beautiful. We have a table here. Does each value of x give you one value of y? And I put this question on a lot of quizzes because students usually get confused because they see the same value of y and sometimes they say it's not a function, but you have to be very careful. The definition is, does each value of the independent variable correspond to exactly one value of the dependent variable? So you can have different values of x which correspond to the same dependent variable. That's okay. There's nothing saying you can't do that. Anyways, this is indeed a function because it follows our definition. X squared plus y squared equals 1. That is not a function because you could have rearranged this equation and isolated for y, or you could have just drawn the circle. It's a radius of 1 centered at the origin. Okay, so for the last example here, this one's a little trickier than the rest because it's not something you've seen before. So what we basically did was we broke down the domain. Now, I know we haven't used the word domain yet in the course, but that's going to be our next lesson. When x is less than or equal to 5, you follow the definition that y is equal to x. When x is greater than 5, y is equal to x plus 1. So if you think about that, both y equals x and y equals x plus 1 are functions. So yeah, what we have here is indeed a function. So I would ask you to revisit this later on and try to graph this after we learn about domain and range, because it is a little tricky to understand how we can change the definition of the relation depending on the value of x. But that's what we're really doing. We're manipulating the domain. So I won't get too caught up with this last example. If you're good with the other ones, then that's great. Okay, perfect.